To do that. Hey! Hey everyone! There's a lot of people here. How are you? Who's here for MongoDB evening? Who's here for free sandwiches? There you go. Hopefully same hands, same people? Okay, if you thought this was some other thing, then, just grab a sandwich and go, because you'll be bored. Because it's all about MongoDB. Yay. Welcome. Some of you look familiar. How many of you were at the full MongoDB day that we had last year over at the Hyatt Regency? I was there. Oh, great. You and me, Kenny, that's it, nobody else.
Really?
I know, I was like, some of the people look familiar. I guess everybody looks, all the engineers look the same in all the towns. So how many of you are like total MongoDB newbies since a lot of you weren't at the thing last year? A lot of you. Cool. How many of you are like MongoDB masters? All right, speakers, speak accordingly, speak slowly, draw lots of pictures. Let's see. Amy, do I have to announce anything in particular? Other than like there's sandwiches in the back and... Oh yeah, wait, that's right. Quentin has a quick announcement. All right, so everyone, for those who don't know, MongoDB has an office in Austin. Ooh, that's right. And we're hiring, and Quentin's going to say a few words about that.
So my name's Quentin Connor. I'm in the engineering group with Mongo. And our little office here in Austin is getting bigger. We're now hiring engineering staff. And I work on the drivers. And we're also, so we're hiring for a team for a software engineer and test to work on the drivers. We need to build a test harness that's common to all the different languages. It's a big challenge. We have to get that done this year. We're also hiring for a technical services engineer. This is technical support for our contract and support agreements with customers, which is kind of what pays the bills. And both of these positions are the type that require software developers to work.
Like hands-on.
So
I'm talking like sitting on the phone.
The driver's work is especially interesting because it covers almost every language. There's about a dozen different drivers for the database, and those are in different languages, of course. So any language you're an expert in, we could put you to work. So thank you.
All right. Okay, and another announcement. If this is so much fun that you want to do like 3 days of nonstop fun just like this, you can come to New York June 23rd through 25th for MongoDB World Conference. It's like 4 tracks, 5 tracks, I don't know, like 1 million different tracks of nonstop MongoDB stuff. So, what's that?
Who's the keynote?
Me? Oh no, wait, I'm not. I don't know, it was like 4 different keynotes.
Mike Olson?
Yeah, Mike Olson from Cloudera and yeah, the Amazon CTO and somebody from Facebook. We got a lot of keynote people. I don't know. I'm going to all the technical sessions. Keynote, that's like for business people or something. All right, I'm going to introduce the first speaker, unless there's something else that I should mention. No? It's all good? All right. You ready?
Ready. Thank you, Asya. All right, good evening, everyone. I am Jake Angerman. I'm a solution architect in MongoDB. I'm the first of 2 speakers this evening. I'm going to be talking a little bit about schema design in MongoDB. I know a lot of you are new to MongoDB. So I will present some schema design considerations and ideas in the context of learning about the MongoDB document model. So as far as an agenda goes, I'll talk a little bit about the traditional database model and how things that you're all used to in terms of normalizing data. I'll talk about how the MongoDB document model is a little bit different. And then at the very end, we'll do an exercise talking about how you would actually model a document in MongoDB. And for those of you sitting close to the screen, I may have a hidden agenda. Okay, so let's talk about the relational model. This is the model that most of you are probably very familiar with. This is the model that's been around for 30 years. This model was created back in the 70s when disk drives were very expensive and storage was a premium. So the mantra was to normalize the data, to reduce repetitions within the data, and to break out the data into different tables. And this is the model that you guys have probably all known and loved for many, many years. It's been around for 30 to 40 years. So this is a simple schema showing a relationship between some different tables, but we all know it's usually not that simple. This is usually what it looks like. Usually, I don't know about you, but when I go into an IT shop and I walk in, I usually see a big wall that has, this big piece of paper on it that goes from, one end of the wall to the other 8 feet high, and that's the masterpiece. That is the master document that describes the data model for that customer. So there are some problems with this. It takes a long time to develop this. A lot of knowledge is put into this, and it's very hard to change it. When you want to, if I invited you, welcome to the team, you're the new developer, now I'd like you to add a new feature to the product or fix a bug, and I gave you that, and you printed it out and put it on your desk, I'd say, good luck, welcome to the team. So this is a very, very difficult thing to change, especially with today's development paradigms. I mean, this normalized model was created back in the day before the idea of sprints, before the idea of cloud computing, before the concept of doing things in an agile fashion. So it's very difficult to change. So I like to think of an analogy here. This is kind of like packing for a trip. So you've got all of your stuff, you got everything packed in there, and it fits perfectly. And you think you're ready to go on your trip, and then your son or daughter comes out with the cello or something. It says, I need to include this in my trip. So now you've got to take all this stuff out and repack it. So it's a lot of effort and a lot of work to make the change. So for example, if I want to insert a new table or insert a new column, Craigslist is a MongoDB user. When your post expires from Craigslist, it actually gets put into MongoDB. They have, I think, like 20 billion documents or something like that. But before they were a MongoDB user, in order to change their schema, if they want to do an alter table against their DDL, it actually took them, over 2 months to do that in production. So you thought your maintenance windows were bad. Imagine trying to alter your tables over a 2-month period. So this is a very complex thing and difficult thing to do when you have a large amount of data, changing your schema and doing production upgrades. Do we have any operations people in the house? No operations people. Wow. Oh, okay, good. So at my last gig, I was the guy up at 3 in the morning doing the schema changes, and we all know how that goes. Like, okay, let's change the DDL. Hope that works. Okay, let's load the new app. Okay, hope that works. Let's do some testing. Oh, it's 5 o'clock. Hope that all worked. So there has to be a better way. So, this is a problem not just for developers, but it's also a problem for operations. So as a developer, I'm just thinking about my problem, my business problem. I'm thinking about objects, right? So if I'm a Perl guy, I'm thinking of associative arrays. If I'm a Java guy, I think about objects. If I'm a Python guy, I think about dictionaries, etc. I don't really think about all the other stuff that happens in order to get my application deployed. So usually what happens in the relational world is you have this object relational mapping layer that kind of solves the impedance mismatch problem between the way as a developer I think about my application and how it's actually normalized and broken up and stored into all these tables in the database. So when I want to roll out a new version of my application, I not only change my code, but I have to change this layer in between, and I have to change this within a maintenance window, change the schema. So as a developer, I just want to think about objects. And in this particular example, I'm thinking about a car. That's the object. So when I change that in my application, this is what really happens. Here's how you store a car in a relational database. So to a relational database, that's a car. I mean, all the components are there. If I want to get the car back out, use whatever metaphor you want. I have to rehydrate all that stuff. I have to do lots of joins, but all the data I need is there. I have to normalize it and put it in many different tables. So how does MongoDB solve this problem? Well, I'll show you in a minute how our document model works, but with MongoDB as a developer, I can think about my problem in my native language, whatever it is. As Quentin said, we have, I think, support for 12 different languages, and I think there's 14, we're up to 14, and we have some other ones that are community driven, but you know, MongoDB is very attractive to developers because it allows them to get started quickly without having to think about the implications of storing their data in a normalized manner. So with MongoDB, I get to be very quick and agile as a developer, but I also get all of the rich features that I would normally get with a database, such as querying, text search, geospatial indexing, aggregations, MapReduce. So I'm going to show you how MongoDB is a different way of thinking about your data in this next section. So let's talk about the document model. Before we talk about the document model, let's talk about some other types of databases that you may be familiar with. So this isn't really a database, but it's an example of a very popular paradigm, and that is a simple key value store. And this is a very natural progression, you know, during the life cycle of an application where you're trying to get scalability and performance, and your first thought is, well, I'll just add a caching layer in front of my database. So that's kind of how key value stores got started. They're very, very fast because you're storing things in RAM. You're basically just taking an object, a bunch of bits, you're shoving it into a memory location, you're getting an opaque handle to it, and when you want it back out, you just pull on the handle and you get your data back out. So it's very, very fast. But the problem is you can't really treat your data the way you would in a database. You can't really query it on anything other than that key, that opaque handle. There's no real schema. You can, if you want to do an update, you can't really update that object the way you would normally do in a database. You really have to replace the whole thing. So you have to pull it out, replace it, and put the whole thing back instead of making, you know, that one change that you want to within that whole object. So very performant, but you don't get into the rich features of a database using a key value store. So the relational record, that's the relational model that we're all used to. It's two-dimensional storage. You can think of it as a rectangle. You can think of it as an Excel spreadsheet. You have a primary key, and you have, you know, fields that point to values. It's very structured. You can query on any of those fields. But the problem is that you run into scalability and performance problems with this issue as you try to scale out. Because you've broken all of the data up into different tables, when you want to query that data, you don't have a lot of locality on disk, and if you want to do some sort of join across a very large number of tables, you basically have to do disk seeks all over the disk to hydrate all that data back into the object that you're looking for. So you get rich depth of functionality, but the performance and scalability have a little bit of challenges there. So let's talk about how MongoDB addresses this. So with MongoDB, instead of just having two-dimensional storage, we basically have n-dimensional storage, and we store it in a JSON document. And I'll show you what that looks like in the slide coming up. So a field is not just one value. It could be many values. So in this particular example, I could have an array that I could dynamically grow as my object is adding more things to that array. I could have an array of sub-documents, so I could embed one document inside of another document. And this flexibility allows you to iterate faster, because as a developer, I don't have to go through this cycle of basically code deployment is exactly that. It's just deploying a new version of code. The application code is actually determining the schema of each document. So when I do a query, I'm basically fetching one document, so it's highly performant. I have to do one seek, one disk access to get that. And that's in the worst case, because in MongoDB, we use memory mapped files, so your data, your working set is in RAM. So best case scenario is you're not actually doing a disk seek at all, you're just going into RAM and getting that out. So you get the performance benefits of a key value store, but you also get the rich functionality in terms of indexing and querying, aggregations, all the things that you're used to doing with a traditional database. So what does a document look like? So a document is basically a JSON data structure. So here's how you would do it in the relational world with normalized tables. Here you're essentially denormalizing the data and putting everything into one document. So in this particular example, I have fields which have values. I could have strings, I could have arrays. So here's a lat long coordinates for a location field, which I can do geospatial indexing on that. I have an array of sub-documents. So here I have an array of cars, which has model year and value. And these sub-documents could actually be shaped differently. Like this could have an extra field or a different field than this other one. And other documents in the same collection, you can think of a collection as a table, they could have slightly different shapes too. So I might have, so maybe it's postal code for London, and for the US it might be zip code. So this flexibility allows you to richly describe your data within a document and store it within MongoDB, basically in a pre-joined, denormalized fashion, which allows it to be very performant. Okay? So a little terminology, this is helpful for people who have a relational background to kind of map what they know to MongoDB. So a document is basically a row. A collection is basically a table. You can think of that, an analog to a table. We have indexing, just like you could in the relational world. A join, you basically pre-join your data in MongoDB by embedding your documents, and we'll talk about that a little bit more. And foreign keys are basically references to other documents. Okay? So, in the relational world came from an era of very expensive disk drives, and you focused on the data storage. That's what you thought about. But in today's modern times, when disks are very cheap, in a document-related database, in that paradigm, you don't really think about how data is stored, you think about how you use it. So in the relational world, you would always ask, what answers do I have? I would basically normalize the data, put it into a relational database, and then let the query planner figure out any question I might ever ask it. I don't really have to think about it, I just let the query planner figure it out. In MongoDB, with documents, you really have to think ahead of time, what questions do I have? You have to think about your access patterns and your query patterns in order to design your documents so that they will be performant when you query them. Okay? So before I get into any modeling exercises, any questions so far? So I can't believe out of 100 people, nobody has a question. All right. All right, I'll keep on plowing ahead then. So I'd like to go through an exercise to show you how you would model data in MongoDB. So let's take a business card example. So here's a famous business card. This is Steve Jobs' business card. So in this business card, we have contact information and the address. So how would you do this in a relational world? So here's an example of two different documents in two different collections in MongoDB that would describe this document in a very relational way. So over here I have a contact, which contains Steve Jobs information. I have a reference here to the ID in another collection for the address. So this is perfectly valid. I mean, this will work in MongoDB. It's a valid way of doing it, but it's not the normal way you would do this kind of relationship. So the way you would do this with a document in MongoDB is actually to pre-join the data or embed this address within the contacts. So that way, when I go to fetch it, I'm only fetching one document. So I'm putting a sub-document within this outermost document, and I'm only fetching one thing. Okay. So there's some advantages to doing this, and there's a lot of flexibility in the schema. So I hear the phrase a lot of schema-less. I don't really like that phrase because it's not really schema-less. It's really a dynamic schema, in that the schema can evolve over time. So as you're writing code, different iterations of your application can evolve the schema over time to accommodate new requirements. So here's an example. Here's the previous example where we had Steve Jobs. Here's Larry Page's business card. And you can see some of the differences highlighted in yellow. So Larry has a fax number, he has an email address, and a URL. So these two documents can coexist within the same collection in MongoDB. That's totally okay. There's no issue with storing two things that have different shapes in the same collection. And furthermore, I can index all of these different things within MongoDB, whether it's a string, a date, elements within the subdocument. I can query all those things using those indexes. Here's another example of things in terms of flexibility that are easily changed. So in the previous example, Steve Jobs, here's the example where we only had one address, but I can envision a situation where some contact within the database might have multiple addresses. Multiple phone numbers is another good example. So here I can just I can update this document in place to add this new subdocument that has an additional an additional address. So I now, instead of having a single subdocument for address, I now have an array of addresses. Okay. All right, so now let's do the final exercise. I'm going to ask for some audience participation here. Let's look at an address book example. So I did the business card example because it shows addresses and contacts. So let's talk about all the different elements or entities you could have in an address book. So I've got phones, emails, contacts. I laugh when I see Twitters. I think that's just a convention to make everything plural. But so how would you model this? So traditionally you have relationships like one-to-one, one-to-many, and many-to-many. So let's talk about each one of those three relationships and how you'd model them in MongoDB. So let's take a simple one first. Let's take a one-to-one. So one-to-one relationships in MongoDB are pretty easy. You basically have two options. You could reference it or you can embed it. So it makes a lot of sense in this particular example. You usually, for a one-to-one, you just embed it. So instead of having that data in a separate collection, in a separate document, you basically pre-join the data and put everything into one document. That's pretty easy to understand. It's one-to-one. It's pretty common. Okay, so here's an example of that. I have a document that contains a name, and I embed a subdocument that contains the Twitter information. So again, it's in one document. It's not in a separate location. All right, and so there's an example of querying. So I said before that you can index and query any of these fields. So I'm going to query on Twitter.account, and I can look for a text string in Twitter.account within all of my documents. All right, let's do the last one. Let's do a one-to-many relationship. So actually, no, this is second to last. I beg your pardon. So one-to-many relationships, you have a couple of options. So let's talk about those options. So here we could do in a traditional way. We could have an array of IDs, or basically an array of references to another collection. That's one way of doing it. Or we could create an array within a contact. So if I have a contact with multiple phones, how would I do that? So here's an example. I would just simply create an array of fields. So I have fields and values. So here's how I would model a one-to-many within MongoDB. Any questions about that? Pretty straightforward, right?
If you have one-to-one or one-to-many, you keep saying you just embed it, but when would you not do that? Does it have to do with the size of the document?
So there are some limitations on the size of a document. It is somewhat arbitrarily set at 16 megabytes. If you had, so let's take an example like a blog posting application, and you have lots of comments to that blog post. As you add comments to that, your array sizes are getting bigger and bigger and bigger. And in MongoDB, it is not very efficient to move documents around the database. So what I mean by that is when MongoDB creates a record within the database, it allocates basically a size to that document. And if you add things to that document, eventually you're going to exceed that size, and the document has to get moved to another location with a bigger pre-allocation. So as you're adding, let's say people are commenting on a blog post, and you've embedded comments, and you keep appending and appending and appending. Eventually, you're going to have to move that document to another location. Well, that's from an I/O perspective, that's very expensive. So that's an example of something where you might want to think of a different schema. There's actually a technique called bucketing. If you do a Google for MongoDB bucketing, it shows you how to handle that case. But in general, you want to avoid document moves in MongoDB. Another example where you wouldn't want to do this is you want to look at the data that's changing a lot. So if you have a lot of embedded documents and the elements within that embedded document are changing a lot, in terms of like you change the name, states isn't a good example. Like I'm trying to think of an example where you're changing the name of something frequently. It would be a real bummer if you had to go through your collection and find every instance of that and update it. So I'm not saying you should always embed, but there are cases when it doesn't make sense. Austin, do you want to add to that?
Yeah, so I mean, one of the ways to think about it is when you fetch the object, if you always want to get all of those n things it's associated with, you want to prefer embedding. If you generally don't want to fetch all of them, you want to prefer storing them separately. We call it linking or embedding, right? So a blog post and comments is an interesting one because you go, well, when I'm rendering a blog post, I want to render the comments. Really, if there's a flame war and there's 10,000 comments, we never want to display all of them, right? We might want to display the first few, or reviews for a product in an e-commerce, right? Anywhere where the user clicks the second time to get some associated information, it's probably better to store it separately.
Another example I just thought of in the blog post case. So I talked about things that you can embed within documents. You can actually embed binary data, so like an image or a JPEG, you can actually embed that. So if you have, let's say you're writing a content management system that has blog posts, etc., you could think of saying have a thumbnail for your avatar of a user. You can actually embed that within a document. And that's something that you're frequently going to fetch, and that might make sense. But what if you're allowed to, have a very large JPEG? You probably wouldn't want to embed that. You probably want to reference that someplace else because you don't want to load that every time. So basically, if you were to embed like a large JPEG or an image, you're unnecessarily increasing your working set, and you're basically using a lot more RAM than you really need to. So infrequently used things is another example of things that you would not want to embed. Any other questions? Okay. So we did the one-to-many. We did one-to-one and one-to-many. Let's do many-to-many. So a contact could be in multiple groups, and a group can contain multiple contacts. So how would we model that? So I'm actually going to show you an example here. So how do you do this normally within like a relational world? Well, you create a join table, and that's just the way that you do many-to-many relationships. Well, you don't do that in MongoDB. You use arrays instead. So let's look at some of the choices that you could do for many-to-many. You could reference, or you could embed. And these are just kind of put on here, not in any particular order. There's kind of 4 choices you can choose from. So I would like some audience participation, and can someone think of one of these 4 options that would make sense for many-to-many? You could also think of it in the inverse. You could eliminate possibilities that don't make sense.
None of them. None of them on their own. I would use 2 together.
Okay.
I'd use the 2 reference ones.
Okay. So you're an Oracle guy. So that's how you would think about that. So let me challenge that. I'm glad you said that because so that is a way to do it. If you did that, then you have to update everything whenever something changes. That's a question you asked me before the talk, right? So let's talk about one possibility. This is the possibility that you brought up. This is half of the possibility that you brought up. Let's say it's a simple address book. So a simple address book, it's something that I pull up on my laptop or using some sort of web-based mail system. I want to look up a contact and see what group that they're in. So one way of doing it is to have an array of group IDs. In all of the examples I've shown you so far, the ID for an object was a number, but it doesn't really have to be. So you could actually design your schema so that the unique identifier within the group collection is a string. So groups could be like, you could have a document called family within the groups. You could have a document called business, etc. So I could actually have an array of group IDs that are the strings of the names of my group. So that way when I look up a contact, I basically have a list of all of those groups in a text format, so I wouldn't have to do another query to go find them. So that's one way of solving that problem. So let's think of, let me show you another way that you may not have thought of. What if you had a corporate email system? So what's the use case for a corporate email system? It's very unusual to look up individuals within your address book from a corporate email server perspective. The job of a corporate email server is to send a lot of email. So what if you embedded the contacts, not with references, but the actual contacts within a group? Then if I'm the email server and I get an email that's supposed to be sent to HQ, which could have thousands of recipients, I could basically go fetch one record, or one document from the database that would contain all of those recipients in one fetch. So that's an example of how embedding it would actually be more performant than using a bunch of references. So if I used references, I could fetch that document from groups, but if I had a list of 10,000 people that I wanted to send an email to, I now have to go fetch 10,000 records over here. So this is a different way of thinking about the problem. By basically embedding and pre-joining that data, I'm doing one fetch, getting all of those recipients in one operation, and it's a much more efficient way of fetching my data. Okay? Does that make sense?
Would these be embedded references to the different contacts? Because what about a situation where you need to look for the contacts as well?
Right.
Would it be efficient to store the entire contact in this context, or just a reference contact?
It depends on your query pattern. And this is an important, so what I mean by that is you need to look at, it depends on your application. Don't you hate it when technical people say it depends? It drives me crazy. It depends, right? So you need to look at it from the way your usage patterns, you predict your usage patterns are going to be. And this is a very important concept in MongoDB. I'm glad you brought this up because, in the relational world, you just kind of normalize everything, let the query planner figure it out. Here, you have to plan ahead of time when you're designing your schema what makes sense. It may make sense in your case. So this is kind of a gray area, which I like actually, because it gets you thinking about some of the possibilities and alternatives that you can have to architect your schema design, right?
Well, and what if your reference is the email address?
So if your reference, that's a unique identifier, right? Nobody shares an email address in your enterprise. So if that reference field happens to be the email address, you don't need to do the second lookup, right? You've got your 10,000 email addresses and you just email to them, right? But it's also available to look up details that may be necessary for other operations.
You can also choose to just duplicate some of the data, right? You don't necessarily, if the access pattern, for the application most of the time requires just maybe email address and name, but doesn't require all the departmental information and whatnot that would be part of that contact record, then the embedded array that represents contacts for the group would actually just be a subset of the information in the contact record. So that's a valid use case as well.
All right, any other questions? So this is a summary slide basically to show you one way of modeling contacts. So I have, this is showing the one-to-one, the one-to-many, and many-to-many. So this example with the portraits over here, it goes back to that question that you asked earlier. Like, it doesn't make sense to have a portrait would be something other than the thumbnail, like a really big image. You wouldn't want to embed that. You would want to have a reference to that someplace else. This is kind of the summary slide, and here is an example of, this doesn't have everything that we talked about in it, but it's an example of a contact document. So I've got arrays of subdocuments, I've got subdocuments, arrays of subdocuments, and a reference to another collection. Okay. So if you would like more on this topic, if you'd like some more education, you can get more education. So this is totally free. If you go to university.mongodb.com, we have free online courses that talks about all this stuff and many other things. We have introductory courses. We have like a developer track for developers. We have a DBA track for DBAs. We just came out with an advanced versions of those two classes, or at least one of those classes, advanced operations. So whether you're a DBA or a developer, you can go to university.mongodb.com. It's totally free. It's a great self-paced program, so you can go at your own pace. As Asya said, this is the download slide. So it's free. Yeah, this is also free, and we don't even ask for your email address either. So you can go to mongodb.org/downloads and click one of these 4 buttons for the operating system of your choice, and it's free to download. It's quick to get started. The tarball's pretty small, and it's easy to get started. Yeah. Yeah, I will. I don't know. I don't technically know the answer to that. I'm pretty sure you can. You can. Okay. All right. I'd have to talk to Amy.
gain access to a recording of this presentation being given by a dozen other people.
Yeah, that's a good point. In addition to the education link that I gave you on the previous slide, that's like self-paced learning. You can do that over a series of weeks. We also have on our website a lot of webinars. So if you search for webinars at MongoDB, it's actually an amazing amount of webinars that you can look at past.
It's mongodb.com/events, and a lot of them are recorded at these type of events. And you get the slides and the recording of somebody presenting.
So we have, so check out the webinars as well. Yes.
Do you have something like stored procedures?
We do not. MongoDB does not have stored procedures. That is not something that we support.
And it makes no sense.
In the case of when you were talking about, it took Craigslist, was it 2 months or 2 years?
It was 2 months to do an alter table.
To do an alter table, and you said in this case you would need to. So I was trying to imagine a situation. So let's say that I was, a developer who hadn't thought much about the data, and I just had something called name, and the name has the first name and the last name, and it's a string, and it's one thing, one object, one field, whatever. And then someone else says, well, actually, we want to have first name, last name. So it sounds like in this system, you could write the new objects into this table.
Correct.
And they could coexist.
That's correct.
But the programs would break wouldn't they? Because now you've got two different types of objects and they have different names, so the query wouldn't work.
So with great power comes great responsibility.
And also many options.
Yeah. So Rick's he knows a lot. I can answer that question, but his answer.
We can all line up.
Yeah, no, actually, this is a really good use case, and this is one of the things that really attracted me to Mongo, is looking at, in this particular situation, exactly what you said. You split that name field, first name, last name. In the application layer at the object, I'm backing that with what we call a document DB object, right? And the getter and setter around the properties of first name, last name would actually look at the schema of what it's looking at. So if I read a record in that did not contain first name and last name, the logic in the getter and setter could actually remediate the data on the fly. And then split that, that existing name field into a first name, last name, create those fields in the backing document structure, and the underlying data layer does not need to be changed. Because when I save that document, it's the same call. So the underlying mechanisms in data access are actually schema independent. And it's the logic at the application layer that actually does that remediation. So these alter tables actually happen on the fly as data is pulled in and out of the database.
That's one way to do it.
I'm sure Asya has another one.
It all depends.
Yeah.
It depends on the requirements.
Other questions? Yes.
Let's take a use case of a time series data. So assume there is a data center and there are several data centers, and whenever any kind of state change happens, an event is fired, and these are like real-time events. So in a day you can expect like several hundred thousands of events that can come across. And these events, there are 100,000 customers who are using, so they are doing different services. Each services can emit different kind of events. Now, we want to model a way through which we track the usage of each of these services, and the usage is measured based on how much time they are using these services, based upon the type of events that are being fired. So, in one way, we will model, like in the time series data, we'll have a timestamp when the particular event was fired, and want to have a series of time series. And for an analytical perspective, for billing and things like that, we want to be able to see, okay, from this date, from this time onwards to this time, tell me how many events got fired, who are my top customers, more events, less events, etc., things along those lines. As you can imagine, in this kind of a data structure, it's much more complex than the example that we demonstrated, because there could be 10 different kind of events. Each event can have embedded information such as CPU, processor, bandwidth, and things along those lines. And you can have multiple data centers, multiple customers, etc., etc. So one of the use cases that occur many times in enterprises would be to query on specific parameters. So in traditional RDBMS words, you will index on certain fields, maybe customer ID, product ID, event ID, maybe data center ID, things like that. Well, in this case, you could have several kind of events, several kind of data centers, products, customers. In fact, you could even do it on the date-wise or quarterly basis. You want to aggregate the data on quarter or a weekly or a monthly kind of basis. In those kind of running those kind of analytical queries on such kind of data that is being generated in a real-time basis, what are some of the best practices what you have seen like implementing MongoDB? How do you design your schema for that, or how do you ensure that some of those queries that, because sometimes you cannot predict what kind of queries users might run on top of the system. So how do you ensure that when we have data which we have billions of records in the system in a month or so, and when you make these queries, they run actually very, very fast?
Right, so there's two parts to the answer to that. One is, how do I design my schema? And the second is an operational question, how do I ingest that data and run those queries, right? So from a schema design perspective, there's no difference in the previous statement that I made. You do need to understand the access pattern. So if you have 100 different dimensions and you have no idea what query pattern is going to show up, that's going to be a very expensive query to run.
Then we use the dynamic attribute schema that just recently described in detail in my blog.
Okay.
You don't actually have to know what the attributes are in advance. You could store them with a type of attribute, true, value, bar, index that, right? But that's not a super common use case. Sounds like in your case you actually know most of your attributes. You probably know what people usually query by, right? So just like relational databases, you have to think about your indexes. You have to think about fast queries, and just like in relational databases, you don't let any random Yahoo run ad hoc queries on the production database. You make them a copy.
Right. So you
have to make that copy.
You said you may not know the access patterns, but you probably know the fields that they're most likely going to query, and that's probably the cardinality of that is probably such that you can create indexes on those, ahead of time. Right.
Is there a limitation on the number of index that, let's say, data center, customer ID, product ID, and ID, and maybe timestamp?
Right.
These are some of the things
Sure.
you know for sure have to be
Absolutely.
kind of indexed.
Yep.
But then there could be customers who may use multiple products, or there could be customers who may commit the same kind of events on the same day multiple times.
Sure.
So vice versa. Same way, like one customer can have many products, and one product can have multiple customers, and those kind of relationships. So would it be safe to say some queries would definitely run very, very slow because you cannot anticipate them, you cannot index on everything because then
You can't index on everything, but you also don't have to allow every query. And people don't get the console prompt on any production system and run whatever they happen to think of, right? They generally have APIs available to them. And
So
that- that's the next talk we'll talk a little bit
just to
about that.
wrap this up, from everything that you just said, it sounded like the cardinality is like less than 10 of the things I could probably query. That does not concern me at all. If you said I have 100, I'd be a little
Jake,
concerned.
there was a question, how many indexes, is there a limit? And there is a limit on the number of
Initial
indexes.
data I said it just looks like that you can only work on one index at a time.
No.
That's not the
No.
case.
Right,
It's not.
understanding?
That's not the case, and there is a practical limitation that you cannot declare more than 64 indexes on a collection.
No, but when you're searching for it,
When you're querying on
you're
some
using
number
only
of
one
fields,
feature, right?
it,
Is that-
well, in versions before the current one, unless it was an OR query, it would only use one index, but
Okay.
would pick of the qualifying index as the one that was most performant.
So has it been updated in the new mixing?
A new one has a way of intersecting indexes, in other words,
Okay,
using
that's
more
the
than
next
one.
part of it.
But compound indexes is still always going to be most performant, same as in relational databases. So,
So is it called compound index now? What is the term?
index intersection.
We have compound indexes as well, right?
Well, compound indexes we've had
Forever.
since before one, four.
Yes, more than one feature intersection.
So what is an index here? And
Same
what's
thing
the
as it is in
overhead?
relational database.
And if I have to reorganize that index,
When you say reorganize that index, that sounds like you want to create a new index
rebuild an index?
on different
So all the
attributes.
usual overhead of that,
It's the same thing, except you would not normally be rebuilding an index unless you decided that that was not a good index, you wanted to add a different index, right? Maybe you used to index on fields A, comma, B, now you go, I really wish I had indexed on A, comma, B, comma, timestamp.
right? You add that index, you drop the first index.
So behind the scene, it's pointers and everything,
It's a B tree index, just like you would have.
and that's in memory too, and
If you're accessing it, yes.
Yep.
Have you run some kind of comparison with HBase and MongoDB and how they perform in a similar
I'm sorry, with what?
comparison with HBase?
HBase.
Different data model. It's different data model means you're going to be representing your data differently, and your queries are going to be different, right? It's like saying, have you compared the performance of the search engine with your database? No, they're different use cases.
So to answer your question, we don't publish benchmarks on our website just because.
We advise you to do that.
Yeah, as a user or a customer, we want you to run your own benchmark because it doesn't really make sense to run some arbitrary benchmark that may not make sense for your application. So we encourage you to, prototype an application, run a benchmark that makes sense for your query patterns and your data, and do that.
Yeah, and if performance is not good, ask them who the users list. Why not? Maybe there's a good index that's missing.
Any other questions?
I think we probably want to.
So we got time for one more, and then I have a shameless plug.
Can you do these huge clusters like Cassandra can?
We're not talking about the operational components of MongoDB in this presentation. It's just schema design, but we can talk about replica sets and sharding, and we have customers. Foursquare has 300 servers and does 100,000 IOPS per second. So I mean, we can grow linearly with sharding. Okay, last slide. That is not the last slide. So as Asya mentioned,
No, use my discount code.
you are required to use this discount code right here. It's required. It's the only one. So in all seriousness, MongoDB World is in June. It's in Times Square. Early bird registration ends, I think it was originally this Friday, but I think they extended it to next week. So if you can use this discount code if you want to go. If you're a startup, and there are rules for what that means. I think it's like less than 100 employees, less than 25 million in revenue, blah, blah, blah. You can actually get 75% off. There's a coupon code for that. So if you're a startup, you can get 75% off. So there are discount codes available. 3 days. There's actually a promotion right now. If you sign up, I think the hotel rate is like 3 nights for $300. So it's like $100 a night for a hotel in Times Square.
$2.99 each.
That's not what the.
It's $2.99. I read the email you.
So was there a clarification on that?
No, it actually said $2.99.
No, that's not what the. Well, anyway. So I encourage you to investigate this. Early bird registration ends, I think, next week. So if you're interested, definitely check it out. And that's it for me.
Need a break, Representative? I can take about 60 seconds.
Are you good to go? The glass surface is working. Here, I got a solution.
Hey, Jake.
Here, solution.
It's like a man. Yes.
Okay.
You have that right.
Ask them to see about it.
It's funny because that's literally exactly how my wife describes it. Yeah. No. It looks like the guys. She's not nerdy enough to know what it is.
Hi, so my name is Ron. I've been a database guy for all my life. I used to write the Sybase drivers. I worked for Oracle, worked for IBM. And then 3 years ago, I picked up Mongo for the first time. So I don't work for Mongo, but 3 years ago, I fell in love with Mongo. So now I walk around with a leaf on my laptop. I walk around with a leaf on my phone. My kids have a leaf on their forehead. No, I'm just kidding. And I think as a database, it's a very, it's funny to think of a database as something emotional, but I think Mongo gives a very emotional experience. Okay, so I started working 3 years ago, or a little less than 3 years ago, doing implementations of Mongo and helping people with Mongo and helping people with security around Mongo and all kinds of things around Mongo. And then all the projects look kind of the same. They all started, very strong. The developers always love it, always have a great time. And then over time, as the database grows and as the database becomes a real database, there are all kinds of other things that have to happen. Okay, you need to give people access to the database. You need to have good QA tools. You need to be able to do workload management. Like Asya said, you don't want somebody to go to the console and run some stupid query. And so what we decided to do is really stop implementations and start becoming part of the ecosystem of Mongo. Okay, so we started building tooling around Mongo, and that's really what this is about. And what I'll do is I'll just describe a few things, show you the way people, the bigger audience does queries on Mongo, how you get reports on Mongo, how you get graphs on Mongo, how you do workload management on Mongo, things like that. And I won't have time to do everything, so I'll just start and I'll get going. So the first thing I'll show you is a set of tools that just help you search and query the database in a way that, the guy who was sitting right behind me was talking about the squiggly brackets, the fact that they start and they run and they, it annoys them a lot that they can't get the squiggly brackets right. I think this happens to all of us at the beginning. Over time we get used to it. So I'll show you, I'll start with that, since that was, and really what I'm doing is I'm connecting to a MongoDB database, but I'm connecting through a tool that helps me write my queries, or helps me write things. And there are all kinds of parameters, like, for example, you see the secondary preferred. That's what Asya meant, that you shouldn't be running these queries on your main database. You should have a replica set, and then you should have a secondary. And then if you run heavy queries, it's no big deal. Okay, so there's all kinds of ways to connect. But when I connect, what I get is at the top, I get all my collections in the database. Okay, and then if I can say, show me only the collections that have the letter G in it. If I click on one of them, I get either a data view or a metadata view. Now, I don't know how much you can see, but what I get here are JSON objects. Okay, so each one of these documents in this particular collection is a tweet. Okay, and it has the embedded arrays and subdocuments, etc. So say that, I'm going to start with a simple use case. I have a collection of tweets, and what I'm trying to figure out is who I should pay off. Okay, so I have a limited amount of money, and I know that some people are more influential than others, so I want to find the people who have a lot of followers and a lot of friends, and maybe saying nice things about me, and then I'll pay them off. Okay, so what I'll do is, rather than opening up a shell and writing the query, I'll write the query through the tool. So, the operator that I want to do is I want to say, show me all the tweets that are tweeted by somebody who has more than, say, 20 friends. Okay, so I pick the operator and I double click on the friends count, so it adds that section of the operator and it runs the query for me. And maybe I also want to do, and it's more than 23 followers, and maybe it's not enough to be 20 and 23, maybe it's 200 and 230. And as I'm modifying these conditions, this is running the query for me. So if I don't put a limit on how many documents I'm getting back, or I'm counting that the cursor has, so this query here has 16,000 documents, and every time I edit something, it drops the number down. So now I'm down to 1,500 documents. That's getting close to where I am okay in terms of paying them off, okay? And under the covers, things always get created as a Mongo query, right? With the brackets, with the projection, with the match. So it's not that it's bypassing or doing the query on its behalf. It's just building the actual query, and then I can copy paste it to my coder scripts. And if I want to say something like, the result set now is all of this stuff, but maybe that's too much data. If I want to create a projection, what I do again is I always go back to the data. So what I'll do is I'll alt double click, right? I'll say I only want the text, and maybe I want the username and how many friends they have and how many followers they have. So every time I do it, you see what it's doing. It's adding the conditions, it's modifying the query under the covers, it's running, getting the result set. And this is now, you know, what I'm really looking for. It's a small amount of JSON documents. Each one of the documents just has the text, the username, the followers count, the friends. If I want to see this as a table, I can get it as a table. If I want to see this, you know, if this were, I'll show you some examples later. I can view this in all types of formats. So this is the first search pattern. It's one that you look at the data, you double click on the data, you build your expression like this. You know, you can add regular expressions this way, etc. The second one is one that's more like a Google search type pattern. Okay, so if you really are putting this in the hand of like an analyst or a data scientist type person, they may not even want to see the JSON data. They may just be typing like a search. Okay, so for example, if I want to add a condition that says it's not enough that you have a lot of followers and you have a lot of friends, you also have to say something nice about me. Okay, you have to say you love me. Okay, so what I'll do is what I want to write is I want to write something like text, and then, you know, it gives me a sampling of the texts that are being sent, but I don't really care about that. I'm just going to put a regular expression. And as I do this again, it dropped down to fewer documents, so only 86 documents, and it built a query, etc., etc. But what you should have noticed is that as I was typing, the thing auto-completed for me. So when I wrote the letter T, it said that there are two fields over there, text and truncated. Okay, and if I would have put U, it would have put all of these, because all of these starts with the letter U. And in a second, I'll explain how that happens, because there is no schema. So where do all these fields come from? Okay, but like Jake said, it's not true that there is no schema. There's just no explicit formal schema, but there absolutely is a schema. Okay, so the idea again here is I can do my selection by look ahead. I can do my projection by look ahead. I can do my sorting by look ahead. Right, again, you say user followers count. Said I want to sort this descending, and again, all the time the query is always being constructed for me. Okay. Okay. So where does all this data come from? Where does this data come from? The metadata that describes the document. Okay. So one of the tools that are, you know, another tool that we created has to do with this notion of mapping the schema, or viewing the schema, or analyzing the schema. Because it is true that one of the most wonderful things in Mongo is the fact that you really can put anything in. And it makes life so convenient. But when you talk to the data architect and you try to explain that to them, they have a fit. Okay, they have a fit. They said, what do you mean you're just going to put it in? Okay, and how do you know what's going to be in there? And how do you know over time what's going to be in there? When do we need to clean things up? And the reality is that yes, it is a wonderful thing, but you do need to keep control over it. Okay, so you either do this by, by making sure that the code doesn't change in certain ways, or at least you should be able to see it. Okay, so the metadata that you saw over here comes from a tool called the Schema Analyzer. Okay, so what the Schema Analyzer does is it goes and samples all the documents you have in your collections, and it depends on a certain configuration that you provided. Do you want it to sample, once a day, once a week, once a month? Do you want it to be comprehensive? Do you want it to sample 10% of the documents? Do you want it to sample by time? Whatever you tell it, it'll do. And then what it does, it goes and reads documents from the collections, and it looks for the fields, and it maps it out. So what you have here is really the view of that analyzer. Okay, so on the left-hand side are all the fields in the collection. Okay, so I have a collection called Geico. Geico has, if I expand it, you'll see that it has a very, very large number of fields. Okay. Doesn't mean that every collection has it, but it does mean that some of the sample collections have these fields. And then for each one of them, what you get is an exact kind of frequency of what happens within it. So for example, created at is a field that 100% of the documents have. So every single document in this collection has a created at field, and that field is always a string. Okay. Whereas, for example, type is a field within the coordinates document, and only 1% of the documents have that, and it's a string. Okay. And if I click it, it'll tell me what they are. Okay. So I have 571 occurrences of point with a capital P and 60 occurrences of point with a lowercase p. And if I click on this, it'll show me what I have in created at, which, by the way, is not very clean, right? I have a date, which was stored as a string. Not that great if I'm going to do any kind of date grade search on it. Okay, and so from an analysis perspective, it allows you to really get the flexibility of Mongo, but keep track of things, clean things up. You can cast things using this thing. And then from a QA perspective, this is good for a data architect. Usually what QA wants is just to make sure nothing's changed, right? They get a new code drop, and they run all the regressions, and they just want to see nothing's changed. So what we do is we give them a visual of this. Okay, so this is a graph that represents the current schema in the system. Okay, so every field has a bar. The size of the bar is the frequency, is how many documents have that field in it, and the color is the type. Okay, and so if you're a QA guy and you get a new code drop, you run all your regression tests, you look at this, you look at the two images, you say, is it the same or not, and you know nothing's changed. Any questions on kind of the ad hoc query and the schema? Yeah.
Could the same field have different types?
Yes, absolutely. The same field could have a different type, and it shouldn't have a different type.
Should not.
Should not. It's not best practice to have the same, but that's one of the things you would see. Like I have an idiotic collection here that has one of each type. Okay. Not only could every field have, but if you look at this graph, you'll see that this goes up to 800%. Okay. You say how could something be 800%? It's a semantic question, but if every document in the collection has a string for a certain field and also has a number in a certain field and also has something else like in an array, then they would have more than 100%.
So what would be its purpose? How would it be indexed?
Well, you could still index them.
Yeah.
By this.
Create an index. An index will index the values for each.
It could be array, it could be the same name. You get my point?
I think that's probably a longer conversation than this.
Okay.
If you want to talk about this, but it absolutely works.
Okay.
Right.
So what is this tool called then? Is it Sonar Finder or JSON Studio?
JSON Studio.
JSON Studio.
Everything is JSON Studio. It's all within one set. It's not broken down.
Gotcha.
And we're so bad with names that everything you said is correct.
Gotcha.
It's Sonar Finder, it's JSON Studio, it's all
You lost your mind.
I lost my mind, but that's okay. It'll be easier for me this way. Okay, and then there's all kinds of there's all kinds of other things like for example, I can create aliases here. Okay, so why would I create aliases? I'll show you. First, I'll show you what I mean by an alias. Okay, if I take another collection over here, okay, you'll see that some of these fields when I look at it, it says like P/B and then price to book ratio. Okay, that's what it says, right? But if you look at the database, you will just see P/B. Okay, and the reason is if I start to grow my collections and I have hundreds of millions of documents, if I have very long field names, I take up more memory and I take up more space because I'm storing that field name. And so what tends to happen is the bigger the collection are, people start reducing the field names. So you end up with having field names which are DT7R, okay, and then you give this to someone from the business and they say, what is this thing? Okay, so we created aliases, so it's so you can compact the way you store your data, but not take away from the usability of the query.
So the alias is specifically
Just in the tool. Yeah. And if I told it to not show the aliases, you would just see P/B. Okay, but these are all part of. It's not exactly that you're building a schema, but you analyze the schema, you can annotate the fields, and then it helps you when you're using it. Okay, any other questions on, yeah?
So, in your previous example, you were saying you were collecting the collection of tweets, all the tweets that are collected. So, is it possible to tokenize each and every word that a person is speaking in the tweet and do sentiment analysis? So just counting the number of occurrences, the frequency of the words that we are more interested in?
You can definitely do that. You'd have to write a little bit of code, and you'd use something like regular expressions, but yeah. I did this with the Yahoo paper, which but it was very primitive. It had a list of words that are positive, a list of words that are negative. You count this, you subtract the other one, and that's your sentiment. You can get really fancy, but simple things are simple. Okay. So that's kind of the and there is one additional important thing. When you're using kind of these queries, you're building these queries, part of it is for your own use, and sometimes the pattern that we saw a lot with users is that people build these queries and then they want it to be used by others, other programs, other users, okay? So every time you build a query, you can save it, okay? So you can do something like, where'd my query go? Oh, because I went to the other application. I didn't save it. Okay, so let me do this real quick. I'll do it again. What was it? Favorites, whatever. Okay. Okay. So I have 442, and again, let me just pick some fields. So once I'm happy with whatever I have, now I can save it. I can call this Austin 1. Okay, call this Austin 1. There's now a saved query. Now what do I do with this saved query? Yeah, I can log out and come back tomorrow and use the query again. But the other thing that this provides me is every time I save a query, I also published a REST API. Okay, so now I can go and make a call through a piece of middleware called the gateway. Okay, and in the gateway, what I tell it is which collection do I want to operate on. Okay, so I can get it, Geico is the collection I want. The name of the query that I want to run was called Austin 1. It's a find. Okay, and then I don't think I need any of the others because that's irrelevant. Okay, so every time, and I can get this in JSON, I can get this in CSV, I can say something like, output equals Perl and pretty print equals 1. Okay, and get it as a output equals Perl. Oh. And I can get this either in a Perl associative array, in a CSV, in JSON, or stick it back into another collection. Okay? So the idea is that I can have power users building these queries and analytics, and then I can have users who are either programmed using Python, Perl, curl, anything else, or users who get this as data back. Okay. So this interface is mainly for simple queries. These are all find queries. So how many of you who use Mongo use aggregation framework? Yes.
I love the aggregation.
I love it too.
It's my favorite.
It is my favorite also. It really is my favorite. Okay, so what is aggregation? So when you first pick up Mongo, especially if you come from the relational world, you say, well, what are these queries, all I could do is a simple select where, or select where sort. Where's the group by, where's the halving, where's all that? And the answer is, don't run to write MapReduce jobs. Take a look at the aggregation framework. The aggregation framework is, in my opinion, so powerful, I can't imagine, as long as you do things within one collection, there's really nothing you cannot do with this, okay? And so, you know, whenever we were doing these implementations, we were doing a lot of aggregation framework code. And at some point, people understood how powerful it was. They said, okay, but we want the business analysts to start writing these things. Okay, but if you didn't like the curly brackets with the finds, the curly brackets with aggregation is even more complicated. So we built a layer on top of that. So it allows you to write fairly complex or very complex analytic queries on top of Mongo without understanding the syntax, without having to deal with this. And I'll write one and I'll show you as an example, and then I'll show you some more complex ones, okay? So I'll start really simple. I have a collection of stocks. Each document here represents a certain ticker, and I'll create a new pipeline called Oz1. Okay. So what I'm doing is I'm creating a pipeline. A pipeline in the aggregation framework is a series of steps. Each step is very, very simple. It's a very simple transformation that is one of a number of types, okay? And these are the types of transformations that are supported within the Mongo aggregation framework. So there's grouping. Okay, so I can say, I define the dimensions by which I want to group, and I want to group all the documents in my collection by those dimensions. Okay, I can filter or match things, so I can say I don't care about these, but I do care about these. I can sort things. I can project certain things. So if my document has 200 fields, maybe I only care about 6 of them, so I project 6 forward. And then 2.6 added 2 more, added redaction, so I can mask or get rid of certain things if it's a security issue, and out, which allows me to put the results back into another MongoDB page. Okay, so I'll show you. I'll start really simple. I'll start with a filter. Okay, so if you look at these documents, each document is a ticker, and each one of them, each company has a sector that they belong to. Okay, so for example, the first thing I want to do, I want to only look at healthcare tickers or healthcare companies. So that's why I did a filter or a match. And then what I'll do is I'll just double click on the healthcare, and it'll add this. And again, if I run the pipeline, which is still very primitive, you'll see that from the starting 6,700 documents I had, now I am only left with 575, and those are all the healthcare companies. Very simple. Next thing I want to do is I want to group things by the industry. So if you look at each one of these companies, each one is defined to have a certain industry. Okay, so this one is in the medical labs and research. Okay, so what I want to do is I want to count how many companies exist within which of these industries. So what I'll do is I'll create a group. Okay, so the next step in my pipeline is a grouping phase, and then I'll double click on the industry, and I'll add a count, because that's always what analytic queries do. They count something. Okay, and if I run it, I just want to see what will happen. Okay, what I'll get is every industry, how many companies there are. There are 11 public hospitals and 8 home health cares and 35 drug manufacturers. And if I want additional aggregations, right, so I'm grouping things together. So a count is just, you can even see what it does. It does a sum of 1 every time, so it's really counting how many there are. But if I want to do something like, I want to compute the total market cap by this industry. Okay, so if you look down here, there is a market cap value. So what I'll do is I'll pick an aggregate value, I'll pick a sum, and I'll double click on the market cap. Okay, run it again, see what happens. Yeah, it's computing the market cap and the number of companies there are. And if I want to do also the average of the price, whatever these things are, I don't know, all the P's. Then I get all the averages. Okay. And then maybe I'm looking at this and I'm saying, well, you know, I really care about the industry that is valued the most first, so that's a sort. Okay, so I add a sort. And I sort on the market cap, and I sort descending, and I run it. Okay, so now I get that the most valuable industry within the healthcare sector is drug manufacturers, okay, and then biotech, etc. And again, under the covers, this is the aggregation pipeline, right? This is what Mongo gets. This is what Mongo can work on. And this is what you pass. And you can see what's happening. There are 3 steps, right? There's a match step, there's a group step, and there's a sort step. But you didn't have to deal with the brackets. That's okay. Like syntactic sugar. Okay. And then there's all kinds of other syntactic sugar you can have. Okay, you look at this, the first thing this has is healthcare. But you say, why would I filter on healthcare? Maybe now I want to do this for healthcare, and later I'm going to do this for technology. So instead of hard coding this, I can put in something a little bit different. Okay, I'll put in something called $$sec. Okay, and if I run this, it'll actually work. And at this point, you know, those of you who've already used aggregation would say, there's something wrong here. This is invalid syntax, and it is indeed invalid syntax, okay? Because this is not what's going to Mongo. If I look at what really went to Mongo, okay, if I check, this is kind of the viewer that sees every single query that went to Mongo, what you'll see is what went to Mongo was sector financial. Okay? Not $$sec and not healthcare. And why did it go financial? It went financial because there's a concept of a bind variable. Okay, a bind variable says there is a parameter called sec. Sec is right now bound to finance. If I bind this to utilities and rerun the pipeline, then I'm going to get something different. I'm going to get electric utilities, diversified utilities. And where this is really important is, again, if you go back to the REST APIs, if I now expose this as a REST API, I can get the user who's making the call, whether from a program or from whatever, to pass the thing that they are interested in and use the same query that I do. Is that okay? Should I show the rest or no? I think it's fine. Okay. And by the way, the bind variable goes all the way to, like, if I were to now visualize this data, okay, and I said, I don't know, create a pie chart, and I don't know, take the industry as the slice, and the number of companies as the pie. Then again, if I change this to technology and rerun the graph, I'll get the right one. Okay, and you can even get the graph on a REST API. You can get a D3 graph through a REST API, rendered back and plugged into a portal. Okay, and there's all kinds of graphs in this thing, right? There's you know, you can let the system decide what the graph is, and it does some analysis on the signal to noise ratio between the different data sets. Or you can tell it that you want a parallel plot, for example. Oh, I'll show you. I'll show you some of the graphs that I like better. Okay. I'll do this now. Okay. Actually, I'll show you this on I think here. Let's try it here. Okay. I should have this somewhere. No. I can't read anything. Okay, yeah, I think. Okay. Okay, so I'm going to do a little. Do this here. Okay. So let me show you a different collection of data, and then some graphs on it. Okay. So what I have here, I have zip code data from the US. Okay, so these are all the zip codes in the US. And every document has the city name, the location, the zip code itself, which happens to be the ID, the state, and the population. And what I have is I have a pipeline that aggregates all the zip codes by city. Okay, so a city can have multiple zip codes. So what it does is it groups it by city, and it sums up the population. So if I run this, what I'll get is every city, how many zip codes there are. So Chicago has 94 zip codes, and total population of 4.9 million in the zip codes that are considered to be Chicago. And this is the average location of the zip codes in Chicago, okay? Okay, so my question to you is this. I'll start with 10 data points, and I'll graph them as a scatter plot. Okay, so you know, this would be Chicago. So my question to you is, what will happen when I start adding more and more points?
Cities will disappear.
Right?
Cities will disappear on what will look like a map.
Yeah.
Yeah, that's cool.
Yeah. So as you add points, this becomes the Verizon commercial. Right? Oh, I'm pressing the wrong button.
Nice, I see Florida and Texas.
Yeah. You see, there's a lot of, and the color is the state. So why is this, so second riddle, why is it slanted all the way to the left or the right, whatever?
Probably Hawaii.
Yeah, Hawaii is down here and Alaska is up here. Okay. I have, which other visualization do I have? I don't know, I'll remember. Okay. Okay, so the next thing in kind of whenever you're talking about getting the data out and giving it to people, what do people like to get their data in?
Pretty pictures.
Yeah, after pretty pictures. What do, yes, exactly. What do highly paid people like to get their data in is an Excel. Frankly, a lot of the analysts don't care what database you use. If you can give it to them in an Excel, they're happy. If you can't, you're not doing your job, okay? So as part of this whole data access suite is a bidirectional bridge to Excel. So I can start with, say, a collection. So I have a collection of documents. Each document is a project funded by the World Bank. And if I do absolutely nothing, just click the download button, what happens is I get an Excel spreadsheet. Okay, so I get an Excel spreadsheet with the data, and this isn't a CSV, this is a true Excel spreadsheet. And there's a difference in this because in a second you'll understand there's a difference between this has to go the other way also. It has to be easy to import the data back into Mongo, okay? So once I have this data in Excel, what I can start doing is work with the data. So for example, if I change this to 2015, and I'll create some, and I'll even create a new column. Okay, I'll call it Austin.mongo. Okay, and I'll make this into a formula, which is this thing minus whatever is in here, and then I'll copy this thing. Okay, this is, by the way, the limit of my abilities in Excel. So there we go. There we go. So I've created a real formula, right? These are not numbers as far as Excel is concerned. These are formulas. And I could even create macros if I knew how to create macros. Okay, and I'll save it so I don't get confused. Okay, and then I'll sync it back in. Okay, so I'll choose that spreadsheet. And I'll sync it. Okay. And what will happen is, first I got this going to 2015. And by the way, you see that it even changed the type, right? It was a string before. If you noticed, it was aligned to the left. Now it's the real number. And I created a sub-document. Now, why did it come back as a sub-document? Yeah, exactly. Okay, so the main question when you look at Mongo going into Excel and back is the mapping, because Mongo is completely hierarchical. You can represent everything, and in Excel, all you can do is put columns. Okay, so the idea behind the mapping is that you follow dot notation. As you go down into subdocuments, you create columns, and the columns have a period in it. okay? And the same goes the other direction. So if you look at, yes, I'm sure you can all see my the names of my columns, I'm sure. But this is Austin.mongo, and if it said A.B.C.D.E, it would have created a 6 deep subdocument inside. Okay, so you can have your users really enrich the data in any way they want, and of course you have to be very, very careful with giving this to them with update privileges, right? Because if they do something really stupid, like they could delete all your data, etc. So the way that I believe this has to be done is you give them a sandbox, you let them play with it, and you refresh their sandbox. You don't ever let them play on the production data unless it's quants in financial services. They can do whatever they want anyway.
Where are the values in the values that you create that formula, and then when you put it back to Mongo?
Then you get the value. Then it recomputes the formula, gets the value from Excel, and puts the value in Mongo.
As a embedded document?
Yes.
And what are the components of that document?
Whatever you put in the column headers. So the first line of the spreadsheet defines the structure, and the rest are always values. Okay. Okay. And again, the question of how a mapping happens, that is completely up to you. You don't, like, I don't have to get the entire spreadsheet. I can go in here and say, I want to get the board approval month and the borrower and the country name, the country short name, and the grant amount, and also this Austin Mongo thing, which I just created, and just download that, okay, and get a partial spreadsheet. So if usually when you have these big projects with a lot of analysts, you usually have one poor guy that's all they do is they get requests. Okay, get me this, and then they do a Mongo export with these fields, and they give it to someone, and then they do another one. And the idea is just it should be self-service. You should be able to get whatever data you want. You shouldn't bother anybody with getting it. Okay, so that's kind of those are examples of the tools on the kind of the data access side, and on the middleware side, and on the REST API side. There's a whole set of other tools that I tried to demo once before, but it gets so boring that I stopped. Okay, so I'll just mention what they are, but I won't try to demo it because it just takes forever. Okay, so there is a set of tools called differs. Okay, so one of the harder things in my experience is that if you're working with Mongo, is that you have to many times compare collections. Okay, you have to compare collections, whether it's because you got a new code version or the data came from somewhere else, and it's no different from relational, right? In relational, you have tons of tools from Ab Initio and Informatica for data cleansing and data this and data that. And for Mongo, it's usually much, much, much simpler, but you still have the concept of needing to very easily compare collections. Okay, so the differs are tools which allow you to take two collections. They could be in the same database, different databases, and just compare them. And they can take data in Mongo and relational data and compare them. Okay, so if you bootstrapped your project from scratch and all your data is brand new, then you wouldn't have to do this. But if you started your data by taking something from some relational database, bringing into Mongo, and then building your application on, then you have to, for example, make sure that the ETL didn't screw up, and all your data did come through, and all your records, because the data is going to look different, right? When you denormalize the data in the way that Jake, suggested, you would have to check that, the join condition under these 5 tables give you exactly that one Mongo collection. Okay, so that's what the differs do. there's a tool called resource management, okay, which is exactly the tool to prevent the stupid things from happening. Okay, so let me talk about this for a second. So first of all, one of the dangerous things, like, okay, you have this ad hoc query builder. Okay, so, you know, all my examples work really fast because my collections are small. So don't let that fool you. I'm fudging it. Okay, if I start with a bigger collection and I just do some idiotic thing like double click on this thing, it could be a disaster. Okay, it could be a disaster. Why? Because if this field has no index on it, and I don't know what the hell I'm doing, and I'm just double clicking here and there, and I run the query, that query is going to run for a very, very long time. Okay. And so there are two ways to solve this. Okay, one is within the tool, and one is outside the tool. So the first thing within the tool, you see what happened when I did this stupid thing, this thing went red. Okay, and if I try to click it, it won't let me run it. Okay, why? Because it does some index analysis. It looks, right, if you look here, you can see that there's no index, right? There's only index on ID. And I'm trying to do something which has no support by an index, and the collection is large, therefore this has the potential of really screwing things up. By the way, it doesn't mean it will screw up. It could be, because it's a find, it could be that I only need to fill in the first 100 documents and it'll be fine, but it still has the potential of screwing everything up. Okay, so the tool will stop you from doing really stupid things.
What's your threshold for considering it to be too large?
So you set that threshold. Okay, so in here you have a few preferences, and one of the preferences, threshold of documents for which an index is required for a query to be run. Okay, so the natural question is, what happens if I'm not only an idiot, I'm an incompetent idiot? So I move this down. Okay, I put this to like this thing. And now it'll be fine. Now, oh no, sorry, the other way around. I make this really high, okay? And if I make this really high and I do the exact same thing, okay, now it's not red. Okay, now I'm an idiot that's doing damage. Okay. So in addition, so whatever we could build within the tool, we build within the tool. But this problem is not a problem of the tool. The tool makes it more likely to happen because you have less technical users querying. But this could happen by any time you have an idiot, right? You have a shell logging in, doing something. You know, I could make a mistake. I could do a $exists query on a field and mistype it. You know, maybe I'm not an idiot. Maybe I'm just tired. Okay. So what we did was we built a resource or a workload manager that sits outside. Okay, so Mongo has, if you have the right privileges, Mongo has two operations. It's called current op and kill op. Okay, and current op will tell you whatever's running right now within the database, and kill op, if you have the right privileges, will allow you to kill it. Okay, so what we built was a small utility which gets a rule set. Okay, and in the rule set you define quotas. You say something like, any connection coming from this IP address and this driver has this quota. Okay, it can run anything up to 5 seconds. Any connection that's not coming from this subnet and maybe coming from a Webster application server, only has two minutes, or a user logging in through here has this quota. Once you have those quotas, what it does is it continuously does a current op, and it checks the rule set, and it looks, once you exceed your quota, it does a kill op. Okay, so it's, again, you have to write your rules correctly, okay, but you have whitelists, you can put your applications in whitelists, you can have kind of fall through rules. If nothing matches, this is what will happen. But that's kind of the other side of preventing stupidity, or, I don't know, controlling stupidity. Okay. What else? I don't know. I mean, I could show you all kinds of little things, like for example, if I go back to the zip code collection, and again, because because it's geospatial data, then looking at the data doesn't have to be through through JSON or through a tabular, right? I can go and look at the data this way. Okay, and again, it's all based on live queries. So for example, if I change the query now, I say, right now, all the dots were in Alabama because I brought the first 10 documents and it was sorted by the state. But if I do a query that shows me if I wanted to get Texas, okay, so I have 1,600 zip codes in Texas. If I want, say, only the major ones, only the ones that have a population over, I don't know, 14,000, say. Okay, so if I plot this now, then it'll give me these ones. Okay, and again, this is live. If I click on it, it'll show me. It'll give me a query that's based on GeoWithin, and the reason we use GeoWithin, and it works with both types of geospatial indexes, both the cluster 2D and the. Okay, so I'm out of time anyway. There's a few more tools. Again, they're all part of this thing called JSON Studio. It's all on the web. You can look on which tools are available on jsonstudio.com, and that's it. Any questions? Okay.
Cool.
Good job.